So let it begin right here, right now. Earth Revolution.
Hello my friends, and welcome to Earth Revolution 2013. We are still the home of the green scene here in Nashville, Tennessee and beyond. In today's show we're going to take a trip to Lutz, Tennessee to meet with Doug and Claudia Kalmer, who have a beautiful passive solar house that they designed and built themselves using the best of both modern and ancient building techniques, a variety of locally sourced materials, and information they got pre-internet from sources like Mother Earth News. They've designed a house that is extremely energy efficient, comfortable, and attractive. In this first of two parts, we're going to look at their attached greenhouse, the solar thermal water heating system that Doug built, this more recently installed solar panel array, a solar oven. We'll also take a look at the back of the house, which is built into a hillside to take advantage of the stable temperature of the earth and minimize the need for heating and cooling inside the house. There's a whole lot to cover, so let's get started. So Doug, tell me and our viewers a little bit about how you built this house, how you designed it to be more energy efficient, when, a little bit about the history of how you did this.
Well, in 1982, Claudia and I moved to Tennessee from New York, and we decided we wanted to live a lower energy lifestyle. And one of the things that motivated me was Mother Earth News, and Mother Earth News had several issues of a sun cottage, they called it, and I incorporated a bunch of different ideas that I'd seen into the design, and Claudia and I came up with a floor plan. But we hired a track hoe to excavate a 65-foot by 25-foot recess into this south-facing hillside. And then we started gathering local stones, and we started slip forming, which is an old building method that enables you to use local flat-face stones to create a stone wall, which we're going to see later.
Okay.
And that incorporates a lot of thermal mass. Thermal mass is any material that helps hold heat. Stone is a pretty good thermal mass, and water is a good one. We're going to see some more of that later too. But the idea being that with all these large windows on the south side, the low winter sun comes in the building all the way to the back of the building, right, and warms it in the winter time, but the high summer sun doesn't come in the building at all.
Right.
So that and direct earth contact, with the rear wall is 7 feet underground, help keep it cooler in the summertime and warmer in the winter.
Okay, because the house is actually built into a hillside.
Yes.
So the back of it is insulated almost by the hill itself, and the walls that were built back there.
Yes, there's the soil temperatures don't fluctuate nearly as much as air temperatures do. So in the winter you might have 0 degrees out here, but you go down a few feet in the soil around here and it'll be 50 degrees.
Yeah.
So it's a lot easier to insulate against 50 degrees than it is against 0, or we've seen it 110 in the shade here too. So.
Right. It can vary a lot.
So it's like anyone who's gone into a basement or a root cellar, it feels cooler in the summer and warmer in the winter, just naturally by the earth contact.
Right. And geothermal operates on the same principle. People who use geothermal systems, water heating and cooling from the temperature of the earth, it maintains a more stable temperature. So you're kind of taking that same idea.
Yes.
With the building materials you've used and the way they've designed it.
The solar water heater on the roof, the solar water collector is part of the solar hot water system. It's a 39 square foot collector, and you see in the upper left hand corner of it is a 10-watt photovoltaic panel. This is a closed loop antifreeze system that 10-watt photovoltaic panel is directly wired to a circulator pump, so that whenever the sun is shining, it's heating the antifreeze solution that's in the collector, but it's also generating a small amount of electricity to run that circulator pump to make that heated antifreeze flow down to a heat exchanger tank that's in the attic.
Okay, and the heat exchanger tank is where the water is.
That's where
the heat into the water.
That's where the solar heat meets my incoming cold water and preheats it before it goes into my electric water heater.
Right. And so the obvious advantage there is somebody who has like an electric heater, a gas heater, whatever, heating their water, before any other source has to kick in, that water's already getting significantly warm.
My electric water heater thermostat is set at 120 degrees. These days, with nice sunny weather like this, we're getting 150 degree water coming into my electric water heater, so it is not cutting in at all.
Right.
Most summers, I've actually installed some bypass valves so that most summers what I do is just bypass the electric water heater completely. That we're getting so much, we're 100% solar, 6 to 8 months of the year
Right.
on the water heating.
Right, with the heating. And then in the winter months, obviously, you use a little bit of additional energy.
Well, I have actually 4 ways of heating water here. The solar provides the most of my water heating, even in the winter time. However, if it's cold in the winter and where it's cloudy, so we're not getting solar hot water, we might have a fire going because we're also not getting solar space heat. Well, I've got a water heater loop on the stack of my wood burner so that the wood also heats water.
Wow.
That's the second way I have it. I also have a heat pump to heat my water, and then all that is backed up by the regular electric resistance heater.
And you've installed all of these things yourself, simply by studying blueprints, or not blueprints, I should say, by studying the information in Mother
Yes.
Earth News and other
Yes.
sources.
Most of it pre-internet, yes.
And do you have an engineering degree?
No, I have an associate's in automotive technology.
So I think the point here for viewers is that this is a do-it-yourself technology, like installing solar thermal, even learning how to design passive solar for somebody that maybe doesn't want to build their whole house from the ground up, but they can do things that you guys have done, very simple things, to
Right.
make your house more energy efficient.
Well, definitely the best money invested in energy saving is in conservation and efficiency. So the first thing you need is a good, well-insulated envelope of the house envelope,
Right.
and weather stripping around doors and windows, and well-insulated shell. But that'll pay you back quicker than anything else. But then beyond that, solar thermal is the way to go, even if it's a simple matter of opening the shades on the south-facing windows during the wintertime.
Right.
Let that sun into the house during the winter and try and keep it out during the summer.
Right.
That's why I have shading devices, and also the white metal roof has made a big difference in keeping the house cooler because it reflects a lot of the summer heat.
Okay, so it naturally keeps it cooler than a standard shingle roof would,
Absolutely.
which is dark and usually absorbs the heat.
Yeah, even I had a white shingled roof on before, and this white metal roof has made a world of difference between the white shingled roof and this.
Right.
The metal is more reflective than the shingles, the asphalt shingles.
So, Claudia, in addition to the solar thermal that Doug was just talking about, you guys also built this greenhouse on the front of the house here. It helps with the thermal aspects of the house itself, but it also helped you guys start your greenhouse business.
Right.
Let's talk a little bit about that.
Well, I mean, the greenhouse itself also helps heat the house because
Yes.
on warm days in the wintertime, we'll heat the greenhouse up, and we'll open up the door to the house, and it'll help add some heat to the house. But yeah, we basically started this greenhouse to grow some transplants for ourselves for the garden. And it turned out that eventually we had extra plants, and we started, giving them to our friends, and from there it ended up turning into a business. We outgrew this small greenhouse very quickly,
Yeah.
and ended up building a freestanding greenhouse where I grow all of our transplants that we sell in the spring for the springtime greenhouse business.
And we'll be taking a look at that in a minute too, the larger greenhouse. But for now, what do you say we go inside this greenhouse and take a look at what's going on in there?
Sure.
Okay.
Yeah. Inside the greenhouse here is sun sugar, cherry tomato plants. We've been eating from them all winter long. I take cuttings in October from plants that we grow outside and start the tomatoes here, and we've been eating cherry tomatoes probably since January.
Wow.
And this is where I start transplants in the winter before we move down to the big greenhouse in February. I fill this up with transplants, and once this gets filled up, we move on down to the other greenhouse. We have a little fan up here that also transfers air, warm air into the house, and circulates warm air into the house when It's in the wintertime.
Yep.
And I'm going to let Doug talk more about some of the mass and stuff, you know.
It's a solar greenhouse in that it doesn't need backup heat because all these large windows on the south side allow the sun to come in and warm these water-filled black barrels and the dark-colored floor pavers. It warms them up during the day. This helps keep the greenhouse from overheating, and it stores the heat for at night. We've not added heat, and we've had down to 3 degrees, and not had it go below 40 in here.
So even in the winter months, you're able to maintain a pretty good temperature in here and keep the plants growing year-round
Yes.
by virtue of these and other ways of
Yes.
keeping the temperature steady.
Yes.
And are you able to get adequate sunlight in here even with the slightly shaded roofing that you have?
Yes, right now there's a shade cloth on it that we put on for the summer to help keep it from getting too warm in here. And we have large ventilated areas, screened areas, that we put foam board panels into in the wintertime. But no, we don't need to add heat to keep the plants alive in the winter, even with low light conditions.
It's
Wow.
never got below 40 degrees in here.
Even though this thermal mass absorbs a lot of the heat, there's still excess heat to help heat the house as well. So the fan or just opening this door helps heat the house in the wintertime as well.
So this is a great design because you've got functions that are working with one another, you know, to just help you in a number of ways.
Well, it's actually a multi-use place. We keep firewood in here in the winter, so it's handy in case we need it and it's dry. We used to keep dogs in here on cold winter nights.
This used to be their little bedding area.
Yeah.
And it's a very low cost. I originally built this for about $300. It's a very low cost addition that anyone with a good south-facing side on their house can build something like this, have a place to grow plants, help with the winter heating, and whatever else uses they find for it. We dry laundry in here sometimes. I mean,
Let me ask you this: what are these windows made of? Are these standard glass? Is this a plexiglass?
all
What is
these
it?
big windows are sliding glass door replacement units. So these large ones are 46 by 76, and because they're a standard sliding glass door replacement unit, they're inexpensive and readily available.
And then you just were able to source the lumber. Did you get that at a regular?
That's just regular 2x4 lumber. It's
Okay.
nothing special. It's all 2x4 framed, and like I said, it's very low cost to build. It's a wonderful place just in the wintertime if you feel like you're not getting enough sunlight to come out here when it's warmed by the sun. It's just a little tropical vacation.
Yeah, exactly. Without leaving home.
That's right.
Very healthy and cutting your food bill because you're getting all this healthy, you know, homegrown food.
Yeah,
That is
and your heat
beautiful.
bill. Yeah, for very low cost. People can build these even without glass. People build them. They don't look so good, but they'll build them with clear plastic sheeting,
Yeah,
and it'll help heat the house, grow food.
yeah,
It doesn't have to be big bucks.
right. So another really cool thing that Doug and Claudia have going on here is this solar oven. And Doug, this is a commercial solar oven. You guys bought this.
Yes, I've built a few, but they weren't as durable and as convenient as this one. This one folds up rapidly, and you can carry it around like a suitcase. It's just easier than using the homemade ones I made.
Yeah. And how does it work exactly? Explain to me.
It's a very simple device. It's got these polished aluminum reflectors that you point it at the sun. I've made this table to rotate. And you point it at the sun, and the polished aluminum reflectors reflect the sun into the oven. It's got a tempered glass cover. It's got a little swing in there to keep the food level, regardless of the angle. There's a leg in the back to adjust the angle of it.
Okay.
And it's essentially like a slow cooker. You can put anything in here that you could put in a slow cooker or an oven. We've baked bread, cakes, cookies, roasts, whole chickens, you name it. You can cook about anything in there.
Wow. And this this little swing, as you say, on the inside, it's metal.
Yes.
It's painted black to
Yes.
absorb more heat.
Yes.
And it's still hot, even at this late hour of the day. And you can tell that you could cook something in there, and it would do a really good job.
I've seen 425 degrees in this thing.
Wow. So you could actually bake cook a Thanksgiving turkey or whatever you wanted,
Yes.
a cake,
Yes.
anything in here. Okay, and these reflect the sun, and this rotates so that if you see that the sun is more south-facing
Yes.
or whatever, or
Yeah.
to the north, you can move that. That is so cool. And how much do these cost?
These new are, this is Sun Oven, and you can go to sunoven.com, and they're, last I knew, around $250.
Okay.
I got lucky and found this at a junk store for $25, and brand new in the box. But
Wow. Oh my God, you did luck out. And people can actually build this too.
yes, they can. The hard thing to acquire is the reflectors, and the polished aluminum reflectors are a little, add a little to the cost, but people can make temporary ones using aluminum foil or mirrors, and they're just not as convenient, or you know, they might be more fragile than this.
Right.
I don't know if people want to see it, but folds up like that, and you can carry it off like a suitcase, and it's very, very convenient.
Is it pretty lightweight?
Well, it is. I've got it bungee down so the
Oh,
wind
I see.
doesn't take it away.
Okay. Other than that, it's perfect. Can you use that in the winter months as well?
Oh yeah,
It'll still
yeah.
heat the food?
You can adjust the leg in the back to suit the winter angle more, and it'll work in the winter.
Wow. Another good investment, folks, if you're on a low budget. This is a way to cook your food without having to turn your conventional oven on and use electricity.
It keeps the heat out of the kitchen in the summertime, and you really can't burn things in here. It's a slow cooker.
Yeah. Solar energy comes in many forms, and this is a good one. Okay, so here we have solar photovoltaic panels, and Doug, you installed these yourself.
Yes.
And tell me, explain, how much energy does this generate? What was involved in installing it?
This is a 4.6 kilowatt array, meaning under ideal conditions it'll produce 4,600 kilowatts. This is 20 230 watt panels. Each one has its own microinverter, N-phase microinverters. They convert the DC electricity from the panels to AC, which goes right into the house. And we can look at the meters
Okay.
in a bit.
Before we talk about those, what did it cost you to install this system?
Well, I bought most of the components in August of 2011, so prices have come down considerably since then on the panels. But altogether, it cost me $10,500 to install this, which works out to $2.29 a watt. The typical installation prices these days to have someone do it for you run $6 to $8 a watt.
So that's significant because you were able to install it yourself.
Yes.
And again, this is stuff that you learned just by going online and doing research and
Yes.
reading about it.
Yes.
It's not impossible for people to do this on their own, or if they have some good help.
If they're familiar with electricity, I had already wired the house, so because these microinverters are out here behind the panels and converting the DC electricity to 240 volt AC electricity, it was something I was already comfortable with and knowledgeable about. However, I did have the advice of a solar installer, and he kind of helped me, coached me along the way, and sold me some specific solar components that I needed.
Right, because he knew the very technical
Yes.
details of it.
Yes, there's a
And
lot
these
to
are-
learn.
Okay, just before we look at those, what panels are these? Is there a particular
These are Canadian
kind?
Solar. You
Okay.
mean the brand? Yes,
Yeah.
they're Canadian Solar. However, they're probably made in China. China's dominating the market on photovoltaics these days.
Which was invented in the United States.
Yes, yes.
So we should be dominating the market, but
Well,
Hopefully that'll
that's a
change.
whole nother thing. It gets into politics and all, but the Chinese have been accused of dumping below their cost panels in order to drive American panel manufacturers out of business.
wow.
I don't know whether it's true or not, but it's actually made a glut of panels on the market right now, and it's an excellent time to get into solar electricity.
Because they're much more affordable now.
Yes.
They're cheaper
Yes.
to buy. Okay, let's take a look at the microinverters in the back of the panels.
All right. One of the things I did to save money on the installation was build my own mounts. This is 1.5-inch galvanized pipe that I could get locally for a whole lot less than the typical solar mounts. And I cut and welded it myself, and then instead of the regular aluminum rails that they sell for about $6 a foot, I just locally accessed 1.5-inch angle iron to mount the panels on, and welded it all up. This was about $1 a foot, so it was a large cost savings there. I decided to go with the technology. The latest technology is microinverters. These are N-phase microinverters. Each panel has its own inverter that converts the DC electricity to AC. And these are what they call plug and play. It's all easy to wire because you just plug the panels into the microinverters, and then the microinverters into a cable that goes down to a box at the end of the array and brings the electricity to the house from there.
So you have wires traveling underground to the house from where
Yes.
that box is?
Yes. It would have been less expensive if I could do a roof mount, but because of shading and several other factors, I didn't do a roof mount. But I still came in well under typical installation costs by doing the ground mount myself.
Okay, and you chose this site because it's wider open, it's not being shaded so much by the trees. You got a lot of trees around here, so
Yes.
this is pretty wide. Do you find that you get a lot of energy? How does it affect your bills? Do you still have to pay?
I don't have any bills anymore.
You didn't-
I get an invoice as to how much TVA owes me. Not only do
Wow.
I not have any electric bills, but TVA pays us over $800 a year for the green energy I put into the grid.
That's amazing.
This is a grid tie. There's no batteries, there's no moving parts, there's nothing to maintain. The panels and the inverters both have a 25-year warranty on their output. So and I've got a 10-year contract with TVA to supply
Wow.
them green energy at 12 cents a kilowatt hour over what their base rate is, what they charge. In other words,
Right.
they're charging us 10 cents a kilowatt hour, they're paying me 22 cents a kilowatt hour.
Right, that was the deal that they had for quite a while, and that was like what they call the Generation Partners program.
Yes, yes.
And I don't know if that price has changed. I think it may have come down for
It's
people
down to
now.
9 cents now.
So just briefly, you built this racking system yourself
Yes.
with materials that you just sourced at a standard, like a whatever, a Lowe's,
Plumbing
Home
supply
Depot, plumbing
and
supply.
metal supply. Yeah.
What did that cost you?
Oh, separately, I can't tell you offhand. I know that these come in 21-foot lengths. One 21-foot length was sufficient to do each stand,
Okay,
and they were about $55 each at the time.
and then you welded all that together. And what about the micro inverter boxes?
I got a deal when I bought the panels and inverters together, so as far as separate pricing, I can't tell you exactly what the separate prices were,
Okay.
because I bought a package deal.
Okay.
And I think that helped bring the price down. At the time that I bought it, like I said, August 2011, it was under $2 a watt for the panels and the inverter.
So, this is important because people who are afraid of investing the money need to be able to see examples of how that can work in their favor. If they can get the money up front to be able to invest even in a smaller system than what you have, not only can they save money on their bills, possibly even eliminate their bills if they have a smaller living space, but get money back.
Just from an economic standpoint, this is a very good investment. This will work out to about 8 to 10% return on your dollar. I figure a payback period of 4 years and about 8 months, and after that, it's paid for itself.
It's free energy
And
for
it's
the
free
rest
energy.
for the rest
and
of the
with
life
a
of the
25-year
system.
warranty, it's a great deal, even just from an economic standpoint.
Right, because if people put money in a savings or a CD or whatever, they're not getting that kind of return. whereas
Definitely
they
not.
can with
And this is
something like
guaranteed.
Yeah,
It's a guaranteed return.
and warranted. Yeah.
Yep.
What's not to love? So
Yep.
this is where the solar energy comes into your house.
Yes.
And explain a little bit about this system right here.
Well, as I mentioned, the microinverters make 240 volts AC, and that's what comes into the house
Okay.
off the transformer anyway. So here we have the solar production meter. Generation Partners is what this used to be called, but this is where the solar energy comes in. This conduit goes to the array,
Okay.
and then it goes through this disconnect. This I feel is it's required by law, but I feel it's superfluous, because any UL approved inverter for solar has to be able to do what they call anti-islanding, and which means that in case the grid goes down, they being the power company, are afraid that a solar array or other generation equipment might put energy back into the grid and electrocute a lineman working on the grid. So,
Oh, okay.
so all inverters have to have an anti-islanding, that if the grid goes down, they shut off.
Okay.
And that's one of the downsides people don't like about grid tied without a battery backup, is that
Okay.
when the grid goes down, you don't have any electricity, even if it's sunny out.
Right.
There are ways to work around that, and there are some inverters that can let you get electricity out of that, but it's problematical and gets more expensive. Because of that, this manual disconnect is redundant. They just feel like they have to have this by law so that they can come in here and pull this, but guaranteed if the grid goes down, the power is not going to backfeed. And so it comes through this disconnect, and this is where it ties into the grid, and this is just the regular usage meter. So I get 22 cents a kilowatt hour for everything that registers, and I get charged 10 cents a kilowatt hour for whatever this registers.
Okay, that's your use and your consumption.
This is my consumption.
And this is what you're generating.
That's production.
That's going to the grid.
Yes.
Okay.
So it doesn't matter how much I use, I still get 22 cents a kilowatt hour for everything I produce, regardless of my usage.
And your production exceeds your usage by what on average?
Well,
it varies with the seasons, I'm sure.
Yes, it does vary with the season, but over the last year, because they ended up paying me $800 after paying off my bills, obviously it's producing about twice monetarily what I'm using, but that's because of the 12 cents a kilowatt hour over.
Right.
Just as far as amperage goes, it's producing about what we use.
Okay. Now let me ask you this: what is the square footage of your living space total?
Total living space, we're living in about 1,200 square feet.
Okay. So that's not unusually small or large home. It's about maybe average. But because you have a lot of other measures that help save energy, this more than covers your energy needs. So.
Yes. But that's what I think people should do first is, like I mentioned, conservation and efficiency.
Right.
Will pay back solar thermal. Solar electric's the most expensive, so leave that for last, folks. Do all the other stuff you can first.
Right, and you talked about weather stripping around windows and all kinds of the basic stuff. Sealing any air leaks and making sure you have good insulation.
Yes.
Thicker walls would be ideal, but...
Well, thermal mass, you can add thermal mass in other ways, but this all pays off better than the solar. It pays off faster than the solar.
Yeah. So this is the back portion of the house, and this is obviously the roof. The north-facing roof, which is built into this hillside. And how far down does this go, Doug?
We're standing 7 feet above the floor level inside the house.
Wow.
We backfilled, we had this excavation dug and then backfilled 50 yards of creek gravel for drainage underneath here, and then topped it off with a few feet of clay. And gutters and leaders and sloping the soil away, we don't have any moisture problems whatsoever.
Okay, and if I had to guess, this goes right down into your kitchen, I believe.
Yeah, we're standing behind the kitchen right now.
So that's pretty cool. Okay, and that also helps tremendously with the...
Yeah, it's the thermal mass of the ground and the idea that it has an insulating quality, that it just remains more temperature stable year-round, whereas air doesn't.
Yeah. Well, it's been an amazing visit so far with Doug and Claudia. In part 2, we'll take a look at their orchard and vineyard, the larger greenhouse where Claudia manages her tomato plant business every spring, the beef cattle they raise, and we'll look at the interior of the house and some of the design aspects there. We're also going to see some of the beautiful artwork they design, as if they weren't talented enough, using stained glass, wrought iron, a variety of materials. So it's going to be a great show. Tune in for the second part of An Afternoon with Doug and Claudia Kalmer. Until then, I'm your host, Susan Shann, for the show Earth Revolution. Peace, love, recycling, and solar energy. We'll see you next time.
So let it begin right here, right now. Earth Revolution.